Now, a quick review from the last episode. This Bulliver Electronics crystal oscillator, which was the standard unit supplied in the Hewlett-Packard 3330B synthesizer, and it was reading high in frequency. Even after adjustment, I was unable to get the frequency to read correctly. All crystal oscillators will age over time, and it appears that this one has aged significantly, that it's not able to be brought back into proper range by the adjustment. On eBay these are listed, few people have them listed. At the price they're asking, I didn't want to take the risk of getting another one that's also aged significantly that I can't adjust it. Further, some other people on the internet that have repaired these synthesizers have noted that the frequency is off once they've actually got the unit running and done some measurements on it. So I suspect that it's a fruitless exercise at this late stage to expect that these are going to be able to be adjusted to within spec. There may be some out there that are still okay, but I didn't want to take that risk. And then, as I can get the Hewlett-Packard replacement, which this is the 10544A, it's not the best crystal oscillator that they made, but it's good enough for this unit and was what was classed as the high stability option 002 in this instrument. So the next step was to manufacture a suitable adapter board. Here is the schematic of the original A40 adapter board for the 002 option for the precision reference oscillator used in the 3330B. CR1, CR2 and Q1 form a regulator for the control circuitry for the oven heater. CR1 is a constant current source, and this particular part I've checked and it's not readily available that I could find. So I thought rather than using this original circuit, I would just use an LM317 as the regulator to give me 11 volts for the control circuitry, just making it simpler using modern componentry. Here is my schematic for the replacement A40 adapter board. Next we shall see the actual PCB layout. In the PCB layout you can see all the writing on the right hand side. These are all copious notes that I made to make sure that I remembered to check various dimensions and fitment, and it's always good practice to document as much as you can, because you can never just remember, well, I certainly can't just remember every single detail that is involved with any project, and it's always good practice to document everything. And just a quick rant, unlike seemingly all other YouTubers that get PCBs made, I didn't use PCB Way. And that's not because their service is not good, but what it is because of freight charges. Here in Australia we expect that freight charges are going to be high, but using the same delivery service, the same delivery company, the same rate, from PCB Way the boards were cheaper, but the overall cost was not, and it came down to shipping. These came from another company, and if people want to know, I'll mention it in the comments, but I'm not about necessarily promoting the company that I normally use for PCBs, but the freight on these was identical in cost to that from PCB Way for the same service from the same company. However, they had a distance surcharge of $33 placed on top of that, and I can only surmise that it's because I live 100 kilometres from the centre of one of the capital cities here in Australia. And if PCB Way can't get a good deal with the courier and my other company can, I don't know what's going on. The bottom line is that these boards cost $4 each. There was 5 of them in total, whereas PCB Way would have cost $5 for the lot. But even with that, factoring in that, overall it was still about $13 more expensive to get these from PCB Way than it was from my other supplier. So just a word to PCB Way, and I've left comments on their website, because when I cancelled the order they did ask me why I cancelled the order, and I told them exactly why. So I'm just hoping that they can review what is going on with the courier and whether they can get that resolved, because at the moment I can't see my way forward to ordering any more boards from them. Today I received the adapter boards for the reference oscillator to go into my HP3330B synthesizer. And here we have, as usually, very well packed. And just slice this open. See how we here we have our boards, and I've kept these in the style of the motherboard. No silk screen, but there is a solder mask, albeit it's only hot air level tins, not gold plate, but it'll do the job. So here we have our adapter board, pretty well ready to go. What we've got to do is assemble it, make a bracket up, and get the oscillator plugged into it, and we can start firing it up and testing it. Here I'm just doing a quick test to make sure everything fits, and we've got a connector here just floating in the board, and the reference oscillator bolted down to the board here. So that all looks quite good, and having put the assembly into the synthesizer in the position that it should be, there's plenty of room for it all to fit without fouling. So what we've got to do now is assemble this, make up a bracket that actually bolts the whole assembly to the synthesizer, then we're pretty well ready to start testing. Using the LM317 regulator here instead of the original circuitry was just simpler, because there was a current source that HP used which I don't know whether I can get hold of. This was a simpler way for me to just use modern components. The rest of the circuitry is identical to the original, so that was really the only change. Here is the partially completed adapter board, and I've got most of the components loaded, and there's the surface mount components on the rear of the board for the 317 regulator. And what I've also got here is an octal plug. This is just straight off of a Chinese eBay listing, and they were relatively inexpensive. What I've done is I've drilled a hole in the centre here, and also countersunk that for the head of the fixing bolt. And what we'll do is we can pop the bolt in there and just rotate. It's a little bit tight, but it does actually go all the way home. There we go. So we have that ready to fix to the circuit board, because I don't want to rely on the not very mechanically rigid 1mm tin copper wire that I'm going to use to connect between the pins and the circuit board. This will add a bit of mechanical strength to stop those wires being fractured under any loading, and ultimately this board here will also have a bracket fabricated which fits underneath the board and is locked in by the mounting holes for the ovenized oscillator, reference oscillator, and then that bracket is bent in a sort of an S shape so that up above here it will actually screw in to the frame of the 3330B like the original oscillator did, and also like the option 2 precision reference oscillator did in the original. So that's where we are at the moment, and the next step is to fix the octal socket to the board. Okay, here's the completed assembly, and all we've got to do now is do a quick voltage test just to make sure everything is working correctly, which it should, but before I put the oscillator in, I want to make sure everything is 100%. So we'll just put this together now. So here's the oscillator, and it just plugs in there like so, and we've got our mounting holes for the oscillator. What I've done here is I've made a special bracket to hold it. We've got some insulating washers just to stand the plate off of the board so that there's no possibility of any shorts. Not that there's much of a problem there anyway, but we can just put these on and get these installed. Okay, and there we are. There's our full assembly ready to go in the oscillator. And the new oscillator, just we get all the cables out of the way, just pops in here like that. And we just simply put these screws in just to hold the whole assembly in place so it doesn't move unnecessarily. And there we are. So that is that done. Okay, with the synthesizer set to 10 megahertz, we are getting on the counter, I'll just zoom in a bit, we're getting on the counter 10 megahertz plus 9.85 hertz. Certainly we have more than enough adjustment range in the new reference oscillator, so there's no problem there. So there we have 10 megahertz and plus 0.01 hertz, which is well within the spec for this 3330B synthesizer. For those of you that are interested, the October 72 edition of the HP Journal actually focuses on the 3330B automatic synthesizer and the HP3330B analyzer section, which the pair of these instruments form a network analyzer. In some of my searching the internet, the HP9845 project pages have a section on HPIB, and here you can see a picture on that page of the rear panel of both a 3330B and the 3570A connected. As you can see here, the connectors are not a standard HPIB or GPIB connector. I'm not 100% sure whether the standard was fully set for the connector at the time. In the case of this network analyzer, what they've done is they've actually used board edge connectors to provide both the HPIB and some interconnecting signals between the two instruments to simplify taking measurements when the system is not controlled by an external HPIB controller. Here we have my cable that I've made up some years ago now, which I've fabricated these out of aluminium stock and wired up standard 0.156 inch dual row connectors, card edge connectors, so that I can interface the two instruments together and bring it out to a GPIB, standard GPIB connection. Now we're going to do a test of the HPIB interface on the 3330B, and I've got here a simple command line interface on a National Instruments piece of software that I have for the GPIB card in this PC. First up, we just type in L for select frequency, 10, and question mark for megahertz, and we say right, and that's now set 10 megahertz on the display. And then if we type in N and 5 and semicolon, we should get our 5 dBm output. We've written that, and we have 5 dBm output. No, we don't. What did I do wrong? Okay, change that and we'll make that semicolon, and now right, and we've now got our output. So it looks as though the GPIB interface is working, and that's another step verified. Here on the 3330B is the next piece of equipment I'll be checking out, and that is the HP3370A network analyzer, the actual analyzer section of this two-piece network analyzer system. And our next goal is to check this out to see if it works. Then if it needs repair, we'll repair it, and then we can actually start looking at getting some software organised to actually control these and do some actual low frequency network analysis. So that's coming up in the next episode.